In this particular video, we are looking at how to determine where a function is increasing, decreasing using the first derivative. And we're going to use this method to find not only where it's increasing, decreasing, but also determine where the maxes and mins are. All right, so first of all, we need to define what this means. Definitions of increasing, decreasing functions. So if a function is increasing on an interval for any two numbers, x sub 1 and x sub 2, where x sub 1 is less than x sub 2, then it implies that f sub 1 is, or f of x sub 1 is less than f of x sub 2. So essentially what that means is, so here you have your graph. Here's x sub 1, x sub 2, f of x sub 1, and f of x sub 2. Right? So then x sub 1 is less than x sub 2, and then also f of x sub 1 is less than f of x sub 2. That means that it's increasing. It's going up. And the second one says that it's decreasing if the opposite's true. So you still have x sub 1 and x sub 2, but now if you look at f of x sub 1, it's bigger than f of x sub 2. Those are your y values. That means it's decreasing on that interval. So that's all that says, right? It's a simple idea, just putting it into a definition. Okay, and generally a function is increasing if, as x moves to the right, the graph goes up, and it's decreasing if it's moving from left to right, the graph goes down. You learned that positive slope, negative slope, right? And the derivative is all about slope, so it makes sense that we're coming back to talk about this. Now, looking at the definition for the test that we're going to be doing, if your first derivative is greater than 0, that means your slope's positive, then that implies that it's increasing. If your first derivative is less than 0, that means your slopes are negative, then your function is decreasing. And if your derivative is equal to 0, that means your slope is 0, then it's a constant, right? So it's horizontal. Your tangent is horizontal at that point. We're going to jump to looking at what the first derivative test is, and then we'll go backwards and do some examples. So basically, for the first derivative test, you know that if you're testing to determine if your slopes are positive or negative. So when a slope goes from positive or from negative to positive, so if your derivative, that's your slope, right? If your slope goes from negative to positive, okay, that means your graph looks like this. That point right there where it goes from negative to positive, that is a minimum. Then if your slope goes from positive to negative, then if it's positive to negative, it looks like that. That is a maximum. All right, so the way that I like to do these is to use number lines. So for example, C is your critical point. And you test a value, you test your values around it. So you test a value to the left of your critical point, and you test a value to the right. By testing the value, meaning you just plug the derivative, you plug that point into your derivative, right? And if you plug that point into your derivative and get a negative number, that means that your slopes are negative. So on this side, slopes are negative. If you plug it in and you get a positive number, that means your slopes are positive. So then looking at this number line, you can see that it goes from negative to positive. So in that case, your critical point designates a minimum. But however, over here, if you plug a point to the left in and you get a positive number, then you plug a point to the right in and get a negative number, then your graph has a maximum at that point, C. Now, there's also some times where it's a critical point right? But it doesn't change values. That means that there you have some sort of horizontal tangent. So if you plug it into the left and it's positive, and then to the right it's positive, then your graph looks something like it's got a horizontal tangent, but it continues to increase. Same thing for a negative, right? It's decreasing, horizontal tangent continues to decrease. Now, let's take a look at this term monotonic. That means, well, mono means singular, right? So if something is monotonic, that means that it's always increasing or always decreasing, just like what we showed you. So if your slopes are always positive, right, then it is always increasing. If your slope is always negative, then it's always decreasing. Right? So that single means that it never changes. It's just always one or the other. It never switches from positive to negative or negative to positive. So then let's jump up here then too and look at the three main guidelines for finding the intervals. So number one, you need to figure out what your critical points are. So finding the critical points is the first thing you need to do. Then number two is test values on the left and to the right of each critical point. It's very important that you test values on each side of each critical number. And we'll go over some examples of what that looks like, but you test each side of each number. And then the last thing you do is then use that to determine intervals where the function is increasing or decreasing. In the examples that we're going to do, I'm going to show you how to do that on a number line. And it's fairly straightforward. You just have to compute several values sometimes. Let's go ahead and look at an example. So first thing we need to do is figure out where the derivative is equal to 0. So that gives us our critical points. Right? We learned in the last couple sections that where the slope is 0, those are your critical points. All right, so the first thing that I want you to do is find out where the derivative is equal to 0. Go ahead and do that. Identify your critical points, pause the video, try that, and then come back. Okay, so you should have been able to find that your critical points occur at x equals 0 and 1. Those are our critical points. So then what I like to do is to go ahead and set up a number line with our critical points on that number line. Okay, those are our critical points. Now, number two, we need to test values around it. So to each side of the critical point, we're going to test a value. So over here, I'm going to test -1. I'm going to test 1/2, and then I'm going to test 2. Right, so I'm going to figure out what is the slope when x is -1. What is the slope when x is 1/2? And what is the slope when x is 2? Go ahead and test those values, and all you care about if it's positive or negative. We don't need an actual value. If you can plug -1 in there and tell if it's positive or negative, that's all that we care about. If we plug these values in, when you plug f of -1 in, you plug that into the derivative. So there's our derivative. We're going to plug -1 in there, and you notice you get a positive answer. So up on our number line, when it's -1, it's positive. So between -infinity and 0, your slopes are positive. And then when you plug in 1/2, right there, you get a negative answer. So between 0 and 1, your slopes are going to be negative. And we don't have to test any other points because our critical points are the only places where the slope could change from positive to negative or negative to positive, right? So any other point in there that we plug in has to be a negative value into your derivative. Then you're going to test when when your x value is 2. And again, you get a positive, so it changes from negative to positive there at 1. Okay? So if we look at what that means between negative infinity and 1, right? It is increasing. Then between 0 and 1, sorry, this is from negative infinity to 0, it's increasing. Then from 0 to 1, it's decreasing. And then from 1 to infinity, it goes back to increasing. Right, so then when you're asked to determine the intervals on where it's increasing and decreasing, this is what we're looking for, right here. Okay, that's how you would explain the intervals at which the graph is increasing or decreasing. And if we sketch the graph, we know that here it's going to be increasing to decreasing, decreasing to increasing. And so this gives you an idea of what your graph looks like, because you have a maximum there and a minimum there. And in fact, that's what we're going to do next, is here we determine where it's increasing or decreasing, but we can also use the same test, same method to determine max and min. So let's try a problem like that. Here, go ahead and try this one. Find the first derivative, set it equal to 0, find your critical points, and then test values on each side, and then use that information to determine where your extrema are. Okay, so pause the video, try it, and then come back. Okay, so when we look at the derivative of your function is 1/2 minus cosine of x. Set that equal to 0, so you get 1/2 is equal to the cosine of x. Then we have to look at our unit circle, so come over here. When you have 1/2 is equal to cosine of x, you want to know where is the cosine equal to 1/2 between 0 and 2 pi, because our interval right here was 0 to 2 pi. And so you're looking at then on the unit circle where your cosine, which if you're looking at the coordinates, is equal to 1/2, and cosine is where the x coordinate is, right? So here's cosine. It's equal to -1 there, radical 3 over 2 there, radical 2 over 2 there, and then 1/2 there, right? So pi over 3 is one of our values where it's equal to 1/2, and then, or 60 degrees, but we're doing radian here. Then you want to know again where it's 1/2. Well, it's -1/2 over here. It's going to be -1/2 again here. So the next time is going to be 5 pi over 3 is our other place where it becomes equal to 1/2. So then we come back over here, and that's where we get pi over 3 and 5 pi over 3 as our critical points. Then you go ahead and put those on a number line and test values to the left and to the right of pi over 3 and 5 pi over 3. And you can again use your unit circle. So I'm going to test a unit or a value to the left would be pi over 4. So I'm going to test pi over 4. And then you need a value on the other side of 5 pi over 3, and then any value in between. So probably the easiest would be just pi, testing pi, and then the other one I'm going to test is 7 pi over 4. Okay, so we're going to plug those values in to the derivative there and test them and see what we get. If you haven't done that already, pause the video and then come back. When we're plugging these values in, you're plugging pi over 4, pi, and 7 pi over 4 into the derivative. Again, the derivative is up here, and so I'm using this as the derivative. I'm plugging all those values in there. So cosine of pi over 4, cosine of pi I get from over here. Cosine of pi over 4 is radical 2 over 2. Cosine of pi is -1. That should be a negative. And then cosine of 7 pi over 4 is radical 2 over 2. So that's where these values over here come from. So you get 1/2 minus radical 2 over 2, and radical 2 over 2 is about 0.7. So then that means that this answer is going to be a positive answer. I'm sorry, it's a negative answer. I said that wrong, because 0.7 is larger, so you would have 1/2 minus 0.7 or 0.5 minus 0.7. And all we care about that's going to be a negative answer. So our answer is negative here. 1/2 minus a negative is plus a positive, so it's going to get a positive answer there. And again, down here, you'll get a negative answer. right? So it goes from negative to positive back to negative. So then come up here on our